Hey Cougars, I'm Mr. Franklin, and in this video we're going to look at two separate issues. The first thing we're going to look at is what's called a gradient sort. It's a tool that we're going to use to sort different ideas to help us figure out which ideas, evidence, um, arguments fit better for different things. So it's going to help us sort our thinking. Then we're going to talk about, and we're going to practice this tool or use this tool to talk about fact, theory, and law and distinguish between those three ideas. So first off, a gradient sort or a gradient, the word gradient literally means change. So in more advanced math classes, you'll actually use the word gradient for the same thing as slope because slope means rate of change. Well, a gradient in upper level math actually means the same thing. You might also see it in color. So when we do a gradient in terms of color, you might see one color change from to another color. So in this case, what we've got is we've got black, gray, and then white. So we're going to have this color change. So we're going to use this gradient pattern to help us sort many ideas throughout this course and build our argument skills in science. So black or solid, we're going to place things that fit our category, the things that fit the best, we're going to place them in the black box up here, okay? If it's gray or fuzzy, we're going to place things that kind of fit, they might fit, or part of them is true for the category, part of it's not, maybe we're not quite sure, but it might fit. And then the white or nothing space, it does not fit. So we're going to drag the images or objects to the box that matches kind of where it fits the overall topic. And then later we're going to be able to explain why did we place it in the correct place. So here's an example that you're going to see when you get this homework, but you're going to get a topic. So in this case, a fact, and there may be an image or a short video clip of a situation that I want you to think about when you're sorting this information. Okay, so this one is a fact, and we've got the car's mass has a mass of 6,000 kilograms. So we drag that up to the black box because it fits the most. The car is white. Maybe it does fit. It is a fact, but maybe there's some confusion as to what color the car really is. Maybe it's not completely white. We could make an argument, so maybe I put it in the middle. And while the force of gravity in this equation is true, it's actually a law. So it really doesn't fit the category of a fact. It's going to fit a different category. So I put it down here. Okay. We could also put like the car is blue. We could put it down here. So that's kind of how it's going to work. But let's do a couple of examples and try it out. So in order to do that, let's review what our terms mean. So first, a fact is a piece of information that has an objective reality. So it's true no matter who the observer is. So for example, if I measure a piece of paper that's 8.5 inches by 11 inches, somebody else could pick up the same piece of paper and get the same measurement. That would be a fact about that piece of paper. So a scientific fact specifically is a measurement that is qualitative or quantitative. So make sure you know those words from your vocab, and it can be verified or measured by someone else. So for example, the example from our video that we watched last week, if it's bright outside, that's a statement of fact. We could say it's bright outside. And if you had a light meter, you could actually give a number to that with a unit of measurement. A hypothesis. A hypothesis is a proposed explanation of an observed phenomenon. It must be tested, and it's the starting point for developing a test. So we observe that it's bright outside, and our hypothesis is it's bright because the sun is out. So it kind of answers the question of why is it bright? Okay, so the sun is out. That would be a hypothesis. Then a theory would be a well-substantiated explanation tested through the scientific method, repeatedly tested and confirmed by observation and experimentation, and can be used to make predictions. So we see that it's bright outside. We go outside and look. Wow, the sun is out. It's bright outside. We go outside and look. Wow, the sun is out. So now we have a theory that every time we see that it's bright outside, the sun must be out. Okay, so that's a theory. Now we could actually shine a really bright light outside, and then now we would have to adjust our theory. A law is a detailed description based on repeated observations, and it is mathematical in nature. And it usually doesn't describe the why. So a theory generally describes the why or how something is working. The law just explains what's happening in a mathematical sense. So for example, the inverse square law for the brightness of a light source, there is a mathematical equation that tells us how bright light is based on its distance from the object, based on the area that it illuminates, all those kinds of things, and we can actually calculate brightness. We change the distance, the brightness is going to drop by a square of the distance. Okay, so that's a law. So we're going to use those definitions, and now we're going to do a couple of sorts. So I'm going to do this one first. I'm just going to work through it. Follow along with your example and see why I picked the choices that I make. And you may disagree, and that's okay. There's a place that we're going to see in a second where we're going to explain that. So here's how this assignment's going to be set up for you. You're going to have a key term, and you're going to try to find facts that explain what you see and observe in this picture. So it looks like we have a truck pulling away. We have a car falling. So now let's go look for some facts. So facts are observed. They can be measured. They're usually quantitative or qualitative. So to me, that's what I'm looking for is qualitative, which is like a description or a comparison, or quantitative, which is a number that deals with the object. So first one, the truck moves forward at 10 meters per second. That has 10 meters per second. That has a number. That sounds like a fact to me. Newton's first law is acting on the car. So that may be true, but that sounds like an explanation of what is happening and not an observation of what is happening. So honestly, I'm kind of not sure at the moment, so I'm going to put that right here for now, and I might move it down here in a minute as we go through this. Force of gravity, I've already said it was a law, so it is a law. It is not a fact in the pure sense of the definition, so I'm going to put it down here. The mass of the car is 6,000 kilograms. So that, I could measure that. Somebody else could measure that and see if that's true. That sounds like a fact. So I'm going to put that up there. I don't like the way the car looks. That sounds like an opinion. So that is definitely not a fact. The car is blue. The car is not blue. Or at least I don't think it's blue. So I'm going to put it down there. The car is white. So that's an observation. Can someone else see it as white? Possibly. There's no number with it, but it is qualitative. Okay, it describes the object. We could say it is white compared to the truck around it. If we had a different color of white, we might argue what kind of white it is. Okay, so that's a qualitative measurement. The next one, the car falls because gravity pulls the car to the ground. So that sounds like an explanation. So yeah, gravity is acting. I know that, but that's not a fact so much as it's kind of a fact. So you see how we might be able to argue this where this falls, but is it a measured reality? Is it a measurement that we actually can observe or make from this image? No, so it does not fit up here. So let's go back. I said I was thinking about this one. Newton's first law is acting on the car. My physics brain says, yes, I know that's true, but that's still an explanation. So we could actually probably argue for both of these to go down here. We could also make an argument that they go up here because they are true, but they are not measured realities that have to do with this, which means this might actually go up here as well. So the gradient sort, most important thing about this is being able to explain why you put your answers where they are, and also be willing to change your answer if you realize that you made a mistake or someone else gives you some input that makes it clearer. Okay, so that's all well and good. I've done the sort, but now for your assignment, you actually are going to need to tell me why you put certain things in the category. So explain what rules or thinking you use to put the items in the solid category. So it says put your answer here. So I picked observations or measurements that were quantitative and qualitative. Notice what I'm doing here when I write this. Oh, I gotta spell that correctly. When I write this is I'm actually using the definition of my fact to help me explain why I picked it. So it's a measurement that is qualitative or quantitative. So it has a number, or it's a comparison, or has some kind of value or description to it. Okay, can be verified or measured by someone else. So I picked observations or measurements that were quantitative and qualitative. They could be measured by someone else who should be able to get the same answer. Okay. So notice I'm only going to explain what I put in the solid because that's what the question asks for. This becomes a little trickier if I ask you, why did you put things in the gray category? Okay, so now you have to kind of think about what definition those fit. So if I'm answering the gray category, then I may have to do some more thinking. But overall, that's actually not too difficult. So I sorted what I observed, and now I'm explaining why those went there based on the definition of what a fact is. Okay, so now let's go and let's try one. So what I recommend you do, this one is for theory. So let's first review a theory. So a theory is a well-substantiated explanation, tested through the scientific method, repeatedly tested, can use to make predictions. And something I didn't put on here, it explains, well, actually, yeah, it does say it. It's an explanation. Okay, so that's going to be a test for reviews. So using that idea, go ahead, pause me, and try making a sort. Which one of these statements fits the idea of theory, an explanation of what's going on, and which ones don't? So pause me and do that right now. Okay, welcome back. Let's take a look at my thinking and see and compare it to yours. So same kind of picture, we're looking for theory, so we're looking for an explanation. Force equals mass times acceleration. I'm not sure, because we can use the equation to explain something, but I don't know. Okay, Newton's first law is acting on the car. That is definitely an explanation. So an object at rest stays at rest, an object in motion stays in motion. That's Newton's first law. Definitely works as an explanation. The car is cool looking. Well, we could definitely argue whether it's cool looking or not. That's definitely an opinion, and it doesn't have anything to do with what's actually happening to the car in the image. The car falls because it's heavy. Okay, well, we might have to argue about what we think about heavy, but does that explain what might be happening? Absolutely, so I'm going to put it. The car falls because gravity pulls the car to the ground. Well, that's also an explanation. Okay, the car doesn't actually fall because the world is round. Okay, so now that one sounds like an explanation. Okay, so I'm going to put it up there, but I have a question mark with that one. Force of gravity, that is a law. We know that that is not a theory. It is an explanation mathematically of what's going on. wait, I just said mathematically of what's going on. So this is true, but that's actually, we could argue is a law, which it is. It's Newton's second law, okay? So it actually is a law and not a theory. All right, so let's go back to this one. The car actually doesn't actually fall because the world is round. I might put this here because it's a weird explanation, but it kind of is an explanation. And sometimes in physics, the weird explanation is correct. This one is actually totally made up. So it actually goes down here. But you could argue, you know what? I don't know much about this yet, Newton's laws or anything like that. So it sounds like an explanation, so I'm going to put it here. It just doesn't sound like a very good explanation. Okay? All right, so let's go look at our question. Explain what rules or thinking you use to put the items in the clear or empty category. So we're going to look at these. What rule did I use in my thinking to put items down here at the bottom? So I'm going to explain that here. Actually, why don't you try explaining it on your own? So go ahead and pause the video and try explaining on your own what you think, why you think we should put those items in the clear category. Go ahead and pause it. Okay, welcome back. Let's take a look at what I think, why I think we put those down there. So first, I'm going to do what I think is easy. Let's do the car is cool looking. So you should try to use complete sentences. For the car is cool looking, I placed it in the blank category because it is an opinion and does not explain why the car fell. For the math equations, they may explain why the car fell, but actually they may tell us values involved in the car falling, but they don't actually explain how things are working. Okay, so we're going to get into this more when we get into our equations, but F equals ma, you multiply the mass times the acceleration and you get a force. A force is causing the car to fall. Okay, so we can use that information as part of our explanation and explaining what's going on, but it doesn't actually explain the causality or why the car is falling, okay? So they tell us the values involved in the car falling, but they don't actually explain how things are working, okay? They don't explain how gravity is doing the thing it's doing. So that's what we're looking at here. Okay, let's do one more. We're gonna do one more, okay? I want you to try this one on your own. Pause it, do it on your own, do the sort, write your explanation, and then after this, you will be able to check your answer, and then you will have some homework where you get to do some on your own. So go ahead and pause it and try this one. This one is a law, so don't forget to check the definition of what a law is, sort the cards, and then tell me why. Okay, welcome back. So a law. Detailed description based on repeated observation describes a phenomenon of nature and it's mathematical. It doesn't exactly explain why or how the mechanics of it actually work. So Newton's law of gravitation gives us a number, but it doesn't actually explain what gravity is, okay? Took Einstein's theory of general relativity to do that. But law, mathematical equation, force of gravity, and put that up there for law. The car falls because gravity pulls the car to the ground. So gravity's involved, that's an explanation. And it's not mathematical. There's an equation, there's a law, there's a number. Yeah, no, that's not a law. The car falls because it is heavy. So that's an explanation. The truck is longer than the car. That's just an observation. And we could actually argue and put this one down here as well, okay? Explain what rules or thinking you use to put items in the fuzzy category. So in this case, I had no items in the fuzzy category, so in a sense, I almost got to explain why. No items fit the fuzzy category because they were either facts, they had mathematical equations, or they were theories or observations. So notice what I'm doing. I'm going back to the definition when I'm explaining why and talking about why did I put things where I put them. Okay, so that's going to be really important as you go further. All right, that is all I've got. So what you're going to do in your next assignment in Canvas is you're actually going to have a series of these that you're going to do on your own. Okay, so you're going to have one that's on facts. You're going to have a different animation. Okay, you're going to have one that's a theory. You're going to have one for a law, and then you're going to have one more that you're going to do. Okay, so I do want to explain what's happening in the video a little bit just to make sure everybody understands, but otherwise you're going to be cleared to go ahead and do this assignment. So this first one, we've got a chair loaded with a book and a little mannequin on top. They push the book really fast towards the chair, and when the chair hits, the book slide forward. Okay, so an object in motion stays in motion. We're kind of following Newton's first law. Objects in motion stay in motion. Okay, so that's going to be the first three. Then the next one, I picked one that you're not going to know much about on purpose. So I want to see what you think. You're going to make mistakes, and that is okay. So part of this is to make mistakes, be able to show your thinking so that we can argue together, we can explain together what our thinking is and correct our thinking as we go along. So I want you to be okay with not knowing the right answer, because you're not going to for this one. But I do want to say what you have is a beam of electrons being shot at this plate. It's supposed to go straight, but they turn on an electromagnet. So this dark ring right here is an electromagnet, and it causes the electrons to curve. So this blue line right here is actually a beam of electrons, and it's curving. So a beam of electrons is bending instead of going straight. There's lots of fascinating things I would love to talk to you about with this, but that's where I'm going to leave it, and I want you to see what you come up with, okay? So you have a couple of slides with that, and that should be it for this assignment. So do your best, explain why you're thinking what you're thinking, and we will discuss it and give you some feedback. So thank you, have a great day, and I will see you in the next video.